DALEC is a new way to build packages and containers for Azure Linux, or your favorite OS distro, using BuildKit. Using a YAML file, we can define a new spec that is used to build both the RPM and the container for your project. Let's see it in action with the open source project Eraser. For this, we're going to define a spec file that determines what sources are going to be used to build the file, or the package and the container, the dependencies we need at build time and at runtime, and then we'll provide some basic build steps and customize how we want our eventual image to be built. So let's start out by checking out the spec file for this. So we're going to build Eraser version manager version 1.3.1. And inside of this file, you can see some front matter metadata about the project, but we define the sources, including the Go mods that we want to use for this, so that we can get everything ahead of time and build a source RPM out of that. So basically when we do the build, it'll be kind of hermetically sealed. No external internet access will happen during the actual build phase. Next, we define our dependencies, both the build time and the runtime dependencies. For build time, we need the Microsoft Go tool chain, Git, Make, and GCC. At runtime, all we're going to need is the OpenSSL libs, because we're going to use the Microsoft Go tool chain to build this in FIPS compatible mode. So it needs to have those OpenSSL libs. Next, we can see a couple of different environment variables that we're setting, CGO enabled and Go experiment. These are really just to help us build our Go project using the FIPS compatibility mode that comes with the Microsoft Go tool chain. Next, we see just a few build steps. Essentially, we're going to run Go build for this project. And then at the end, we'll use Go tool to look at the symbols to see what's there. We can define what things end up into the package. So we've got just the Eraser Manager binary here. That's the thing that we're going to build up here. You can see it's being outputted there. Some basic tests on the RPM to see what the file permissions are and make sure that the file's in the right place. And then finally, the image that we want to build. In this case, we're going to use the CBL distroless minimal image of Mariner as the base image. The entry point that we want for this container is going to be /manager. And then because we are installing with a RPM, we're going to have that binary land in /bin manager. So we want to do a symlink between that and /manager, because that's what the entry point expects. All right, let's give that a shot. So the first thing we're going to do is use Docker build X to build this. So in this case, we're going to use Docker build X build. We're going to specify the platform we want is Linux ARM64. We're going to output that to a directory called output RPM. And then we're going to specify the file we want to use. In this case, the spec file we just looked at, along with the target that we want to run. And in this case, we're only going to output the RPM. So we're going to specify target of Mariner 2 RPM. Now, while this runs, we can see that it's referring to a DALEC front end. DALEC is implemented as a front end for BuildKit. It understands how to turn that spec file into the necessary BuildKit steps behind the scenes. Okay, so now this is done and built. We can take a look at the output RPM directory, and we see that we have the source RPM that was built for this, along with the ARM64 RPM for Eraser Manager v131. Now we can do the same thing, but build it as a container image instead. And in this case, I'm going to output that as an OCI layout so that we can see the pieces of it on the file system. Basically the same build, just changing the output a little bit and specifying a different target. So in this case, the target's going to be Mariner 2 container. So when we run this, we'll see some pretty familiar build steps and a lot of cache steps from the previous step, installing the RPM that we built in the previous step, adding that symlink that we mentioned in the spec, and then exporting all of that out to the file system. So now, if we were to take a look at the layouts directory, which is what we specified in the output command, we can see that this generated an OCI layout for us. And if we take a look at layouts index.json, and we'll pipe that to JQ so it's a little pretty, here is the OCI manifest that was created for that. So if we look in the directory, pipe it to JQ again. Here is our OCI image, and you can see the different layers that came along with that that make up the application. All ready to go. We could take that and push it to a registry. And we could actually specify that as an output for pushing directly to the registry when we build. This allows us to do some fun things on the file system if we need to, but really showcases the interaction and the integration with BuildKit and how flexible it is, requiring almost no tooling, just having Docker available. And you're able to build both containers and RPMs to install into Azure Linux.